Let's take a look at the questions on homework number 26. The first section is asking you about transformational geometry. Number 1. A sequence of transformations was applied to a rectangle in a coordinate plane. The transformations used were translation, reflection, and rotation. Which statement about the resulting figure is true? You need to focus on the fact that the 3 rotations that were mentioned are rigid motions. And all rigid motions result in congruent figures. So we cannot be similar, and we cannot maybe be a rectangle. We must be a rectangle. And we must be a rectangle that is congruent. All the side lengths will be the same, and all the angles will be the same as the original. So the answer here is A. For questions 2, 3, 4, and 5, they ask you to use this single point and transform it using the description here. A reflection over the y-axis changes the sign of the x-coordinate. So A prime will be positive 7, 5. A reflection in the x-axis changes the y-coordinate. So B prime will be negative 7, negative 5. A translation 5 to the right adds 5 to the x-coordinate, and 3 down subtracts 3 from the y-coordinate. So C prime will be negative 2, positive 2. A translation 2 up is adding 2 to the y, and 4 left is subtracting 4 from the x. So D prime will be negative 11, positive 7. The next section asks you to write the linear equation for the graph shown. For each y equals mx plus b sentence, you need to first know the y-intercept, which is the b value, and then you need to find another perfect corner point so you can find the slope triangle fraction. So for this first one here, we have a y-intercept of 2. You can put it at the beginning, or you can put it at the end of the sentence. The slope triangle is a rise and run, and that number is next to the x. For the next question, we have a y-intercept of 1, and we have a rise of 1 and a run of 2. So the slope is positive 1/2 x plus 1. Number 8 is a special equation because it's a horizontal line. When you have a horizontal line and you only cross the y-axis, that means you only get a y in your sentence. Since we cross on the number line at negative 4, our sentence will be exactly y equals negative 4. The next question asks you to simplify this expression. And when you multiply like bases, you keep the base the same, and you add the exponents together. So we're going to add negative 3 plus 6, and that's going to give us 7 to the 3rd power. For numbers 10 and 11, you're going to use your exponent rules to simplify each expression. 10a requires you to do 2 things. First, it requires you to simplify the numerator. Then it requires you to divide this quotient here. Negative 5 minus negative 3 is 4 to the negative 2 power. If you still have a negative power when you're finished, you take the reciprocal and make it positive. Letter B. X divided by x, you keep the base the same, and you subtract the powers. 6 minus negative 4. Be careful here. 6 minus negative 4 is going to result in x to the positive 10. Letter C, there's not much to do, except to make this expression positive, we need to take the reciprocal. For number 11, we'll subtract 5 minus 7, and that will give us 2 to the negative 2 power. We'll take the reciprocal and make it positive. Don't forget, when you distribute a power, you distribute it to every exponent. So that's going to be 3 to the 8th, m to the 12th. And letter C is a multiplication of like bases. Keep the base the same, add the powers. The next section asks you to write it in slope-intercept form, where the y is isolated and the x term and the constant term are on the other side. So I'm going to use the addition property of equality here. I'm going to use an additive inverse that will take that 3x and move it to the other side. Number 13 is similar, but I'm going to use the subtraction property of equality. And it doesn't matter what order you place these items in. The constant can be first, or the coefficient can be first, as long as the signs are correct. You need a positive 12 and a negative 3x. Number 14 requires me to divide every single term. And the same with number 15. Sometimes the division results in a nice integer, and sometimes it doesn't divide evenly. And when it doesn't divide evenly, we simply leave it as a fraction. You could write this in reverse as well. The last section asks you to find the rate of change from the given points, and rate of change is found by calculating the change in the y divided by the change in the x. Our y values are 3 and 4, and our x values are 7 and 5. That results in a negative 1 over 2. Number 17, our subtraction fraction will be filled with 8 minus 4 over negative 4 minus negative 2. Watch your signs and use a calculator if you need to. Reduce if possible. The last one. For these last two questions, you may want to use a calculator. We've got some distribution to do on the right-hand side, so I'm going to leave the negative 25 the same, and I multiply negative 2/3 times 18. And I'm going to multiply negative 2/3 times 30. The plus x will remain the same. I'm going to combine like terms on the right-hand side. Next, I'm going to move this constant and finally I'm going to divide by my coefficient. This will result in a decimal value, so I'm simply going to leave my answer in simplest fraction form, just like that. For the last question, when I distribute on the left, I get 12n plus 2, and the minus 3 stays at the end. On the right-hand side, I'm going to get 12n minus 4, and the plus 3 stays at the end. When I combine like terms on each side, oops, that's supposed to be an n, I'm going to get 12n minus 1 equals 12n minus 1. Do you see it already? We have a perfect match. When you have a perfect match on both sides, that's infinite solutions. If you're not sure, you could always continue to use your inverse operations here until you see that it's a perfect match, or see that we have a sentence where 0 is equal to 0. And that concludes homework number 26.